Hey guys, this is our wind tunnel course project, and this is the design review for our project. So here we have the can where we burn the incense inside. The smoke rises up through this tube and goes through here, and then goes through the straws to make nice streamlines. The fan on the end here sucks the smoke through, and as it goes through, it passes around this airfoil. And then the fan also blows air down through this tube and blows air back into the back of this can to feed the incense flame.
Potential flows describe the motion of fluids. There are 4 types of potential flows: uniform flow, source and sink, vortex, and doublet. You can use superposition to add together these potential flows to get more complex systems. And from these complex systems, you can find their stagnation points to figure out where the velocity should be equal to 0. You use these potential flows to figure out how to generate lift, along with find ways to minimize drag.
Now we're going to run through some of the math. And so we start out with our tables. We're given the stream function and velocity potential for uniform and doublet, and we combine the two with superposition. And then we're able to derive the different velocities. And here we're looking at the maximum velocity on the surface of the cylinder.
Yep, and then we use Bernoulli's equation to find the pressure on the surface of the cylinder. And then using that, we can derive the force and then break that up into the drag and lift force.
So now we can take a look at some actual flow fields that we made using our wind tunnel. So on the left side, you can see the uniform flow, and on the right, where the air is being sucked in, you can see a sink, and the cylinder in the center acts as a doublet, with a source on the front end and sink on the back end. So when we zoom in here, we can get a better look at where our stagnation points would be on the front and back end, our max velocity points on the top and bottom, which have a value of 2 u0, which correspond to the velocity from the uniform flow. And of course, superposition tells us that the uniform flow fields will look like this, these doublet flow fields will look like this, and the resultant flow around the cylinder ends up looking like this. Now that we've taken a look at this, we can look at some other airfoils.